All right, I'm going to start this lesson by asking you a question. The question is this: how can you list all the numbers that lie in the shaded region on that number line? So at first, without much math background, you might say, well, I can list it out like, well, -2 is here. With a little bit of math, I know that that open dot means that it's not included in that list. So let's go a little bit to the right and say -1.9. And then let's say -1.8, -1.7. But then I say, well, what about all the numbers between -1.9 and -1.8? And you say, oh yeah, well, maybe -1.85. And then I ask the question, well, what about between -1.9 and -1.85? And then we can repeat that process, and we can never get a true list of the numbers that lie on that number line. So this method is no good. So what's another method? Well, we know in everyday life when we're trying to say, if I was to tell you to come between 1 o'clock and 3 o'clock in an email, let's say, I might say, come between 1 and 3, and it's understood that you can come anytime between 1 and 3. Well, let's try that here, okay? So this was not mathematical. So let's say, okay, our numbers lie between -2 and 3. But what does that look like? To me, that looks like -2 minus 3. So that doesn't work. So here we have the idea of an inequality. And an inequality allows us to say that we're between two numbers using symbols. So how do we do this here? Well, we know, let's call the number that I'm trying to describe. It can be any number between -2 and 3. That's the words. Now, how do we do that in symbols? Symbolically, what this is going to use is inequalities. And inequality symbols allow us to write this statement, which we would see normally in everyday life, in math terms. So what we want to say is that x is bigger than -2, and strictly bigger than because of this open dot, but less than or equal to 3. And we can be equal to 3 because of this closed dot here. So let me write this down. Our value, x, that lies in the shaded region, is greater than -2, and at the same time, x has to be less than or equal to 3. So once again, strictly greater than -2 because the open dot, less than or equal to 3 because of the closed dot. The closed dot tells us that equal to part. Open dot, no equal to. All right, so now, can we write this in one string without the word and in there? And it turns out we can, and this is how we do it. So we have x is between -2 and 3. So how does x compare to -2 if x is on the right side? So this is why in the diagnostic I had you answer the question if the two inequalities were equivalent. Because if you understand that, then you'll understand this next part, which is -2 has to be smaller than x. And this is set up just like this so we can keep that symbol exactly the same. This right here is inequality notation. Okay, and that's what we're going to be using in this class. In this course, this is one of 3 notations that we're going to use. So, inequality notation is one. The second notation that we're going to use is what's called interval notation. So, interval notation. Interval notation uses parentheses and brackets instead of these inequality signs. Okay, so I'm going to write in interval notation this interval from -2 to 3. So it's going to look sort of like an ordered pair. Okay, you have -2, then you put comma 3. Now the way we notate that is we want -2 to be the smallest number not included. So we're going to use a parenthesis to signify that a number is not included in the set. Okay? Then what about the equal to? If you have an inequality that can be equal to a number, well, that one we're going to use a bracket. Okay? So that is interval notation. Finally, the last notation is called set notation. Set notation, whenever you want to write a set in mathematics, you use the curly brackets. Okay? So set notation starts like this. You start with a curly bracket. You write whatever variable you're using. In this case, I used x. You put a vertical bar. That vertical bar, once I write this full statement out, I'll write the words that goes with set notation so you understand what the vertical bar means. But the vertical bar is such that. So the way you read this so far is, it's the set, the curly brackets tell me set, of all x's such that, and then you just put in your inequality notation. Okay, so in words, this reads, the set of all x's such that, and then hopefully you're able to read inequality notation. All right, so we have another example here. And this time, our number line is shaded from the left end all the way to the right end. So what does this mean? It means that every number on that number line is going to be written in our solution. So we're going to have to write that in inequality, in interval, and in set. So let's see how that's done. Okay, this set is what's known as all real numbers because our number line is a number line of all real numbers. Okay, so in inequality notation, we always start from the left and then go right. Okay, so what's the number furthest to the left? We call that number negative infinity. Now, is negative infinity actually a number? Can you actually get to negative infinity? The answer is no. Negative infinity is not really a number. It just signifies as far as you could go to the number line to the left. Okay? So, with infinities and inequality notation, you never use the less than or equal to signs. Okay? Or if you have to use the greater than or equal to sign. It's always strictly less than or always strictly greater than. So, our value is going to be between negative infinity and what's the number all the way to the right? It's positive infinity. So there is inequality notation for what's shaded on the number line. All right, now interval notation. How do we write this in interval notation? Well, once we have inequality, we can write interval pretty easily. We know that since it's strictly less than, we're going to use parentheses. Then we put in the two values that are our endpoints. And then parentheses on that side. Okay. In set notation, we have the set for all x's such that so we have something a little bit different for this one here. You could technically put inequality notation right here, but I want you to see this just in case this is ever written, that you know how to read it. So this says is a element of, or in other words, you might hear the word exists. So it's the set of all x's such that x is an element of, and this r is the all real numbers. Symbol. Okay, in all of these, if you just wanted to state all real numbers, I'd be okay with that. So then the question comes, well, why did you just spend 3 minutes explaining each of these notations? Because if I give you this notation and ask you to interpret it, I need you to know how to read it. Okay? So that's all for that one. All right, so last example for this video. I want to show you what it looks like if we have from a number to positive infinity. So that's what's shown on the number line there. So if you'll notice, 1 is included in the set, and then it goes forever to positive infinity. So in this case, let's start with inequality notation. Our lowest number in the set is 1. 1 is included, and it's going to be all numbers bigger than 1. So 1 is less than or equal to x, and x has to be smaller than infinity, so that's less than infinity. All right, in interval notation, we're starting at 1. 1 is included, so it gets a bracket, comma, the right side endpoint is infinity, and you can never include infinity. Okay, in set notation, it's all x such that 1 is less than or equal to x, which is less than infinity. Now, I want to mention one thing. When you have a set like this where you're starting at a number and going to positive infinity or to negative infinity, you can also write the inequality notation like this. You can write, instead of this notation, you can simply write x has to be greater than or equal to 1. So that means on the set notation, you could also write, these two things would mean the same. Just like these two are the same. So, hopefully this helped you out a bit. We'll move on to domain and range in the next video.